Assalamualaikum and hi everyone. So in this video lecture, we are going to cover on another force quantity called moment. Bukan moment as in moment indah kind of thing. That's cheesy. So the moment that we are talking about here is the engineering mechanics kind of moment. Okay. To make it more convenient in your learning process, I am going to split this video into 3 parts, including basic of moment, cross product and vector formulation, and principle of moment, so that it is easier for you to refer to respective sessions in short video series. So make sure you watch all 3 videos before marking your online attendance for this particular session. Okay? Arasa? So in the previous lecture series, we are dealing a lot with common forces which have a straight line kind of trajectory. So when we apply the force to the body will move in straight line motion as well. But sometimes in certain situation, when we apply the force to a body, instead of moving in linear or straight motion, there is a tendency for the body to rotate instead because of the fixture. Such tendency to rotate is called torque, or in this lecture, we are going to call it as moment. You can see the concept of moment when driving, whereby you apply the force to the steering wheel, which causes the string to rotate at one point. Another application is probably the scary ride at the theme park. This is one thrill ride at the Sunway Lagoon theme park. I really hate this ride, by the way. It's so scary for me. Also, you can find the application of moment at a bridge joint, when load of force are applied along the bridge, as in the weight of the vehicle passing by the bridge. There is actually a tendency for the bridge to rotate at point A and point B, which causes the bridge to bend if it receives excessive load. Okay guys, if you look at this picture, it shows a force from the hand rotating the wrench at a distance labeled as D. So, the magnitude of moment can simply be calculated by multiplying the magnitude of the force F with the perpendicular distance of the force with the axis of rotation. So, you have to make sure when you select the D value, it must be 90 degrees to the line of the force. The direction of the moment can be determined using the right hand rule. The 4 fingers will point towards the direction of the force and the thumb will show the direction of the moment. So normally in 2D plane, we assume counterclockwise or lawan jam as positive direction, while clockwise or ikut arah jam as negative direction. Let's do a quick exercise with this example. So in the first picture, we know the force is 100 Newton. Direction of the force will create a clockwise kind of motion like this. Okay, so the D or the distance which is perpendicular to the line of the force is over here. So if we want to calculate the magnitude of moment equals to FD, so our F is 100 Newton and the distance is 2 meter. So you will get a corresponding moment of 200 Newton meter. So don't forget to include the direction of the moment. In this case is clockwise direction. Okay, let's look at the second picture. This is the direction of the force. So if you want to know what is the distance of the line of force to the rotational axis, you just elongate the force punya line tu sampai it reach the rotation axis. At a point where the line is perpendicular or 90 degree with our line of force, so that would be our D or distance. So if you want to calculate the magnitude of moment equals to FD, our F is 50 Newton and the D in this case is not 2 meter. Oops, it is actually 0.75 meter. Okay. So the magnitude of moment for this case is 37.5 Newton meter. So this kind of force will create a kind of clockwise kind of direction. So please include the direction in your answer as well. Okay, as for this picture, let's do this in a new sheet. Okay, so this is our line of force, which is 40 kilonewton. So if you want to know what is the D, you just elongate the force line and then you connect the axis to the line of force, so that the line is 90 degree to the force punya line tu. So your D or your distance will be from here to here, which is 4 meter tambah dengan 2 cos 30 meter. So you can substitute all that value into the equation whereby magnitude of moment equals to Fd. Your F is 40 kilonewton. Your D is 4 meter campur 2 cos 30 meter. The corresponding magnitude would be 229. What is the unit? Okay, tadi kita pakai kilonewton for the force and the distance is m. So the unit is kilonewton meter. So let's check out the direction. So this kind of force will create a clockwise kind of direction. So please include that in your final answer as well. You should get the idea by now. So in this example, this is your line of force. So you just elongate it until it reach the O axis and then create a line which is perpendicular to the line of force, and that would be your D. So your D in this case is 1 sin 45 meter and your force is 60 kilonewton. So you can calculate the magnitude of the moment simply to be 42.4 kilonewton meter. So this kind of direction, kalau you tengok dia ke kanan, and then there is a tendency for it to rotate counterclockwise. So include that in your answer as well. As for the final example, if this is your line of force, kita elongate until it reach the O axis too, and then the distance is perpendicular to the line of force. Okay, so in this case, if you want to calculate the magnitude of moment, it will be equivalent to Fd. The force is 7 kilonewton. Kalau tengok ni, the distance will be 4 meter minus 1 meter. So the magnitude of this moment will be 21 kilonewton meter. So kalau tengok the force is moving to the left kan, so there is a tendency for it to rotate counterclockwise along the O axis. So please include that direction as well in your answer. Sama je macam konsep resultant force, summation of moment can also be calculated by summing the total force multiplied with its respective distance. So, if this is your axis, and you have 3 forces of 1, 2 and 3, which causes the body to rotate, total moment can be calculated by totaling up the Fd values for the 3 forces. So in this calculation, very commonly, we need to assume the counterclockwise direction to be positive. So, based on this figure, you have 3 moments that you have to sum. Moment 2 is negative, notice, because it have a clockwise direction. Finally, each moment will have its own Fd value. Just tambah everything and you will get your resultant moment. So let's look straight at this example. In this example, you are required to calculate what is the resultant force caused by these 4 forces. Okay, so from the previous slide, we know that assuming counterclockwise direction to be positive, the resultant moment would be equivalent to summation of F multiplied with D. Let's check out the first force over here dulu. So we're going to call this force to be F1, and then you elongate the line of force so that you will know what is the distance of the line of force to the rotational axis, which is D1. So the moment for this force would be F1 multiplied with D1. Okay, now look carefully. The direction of force is downward. So there is a tendency for this kind of force to create a clockwise kind of rotation moment. So your F1 D1 would be a negative value. Repeat the same procedure for the second force. So we are going to call this force to be F2. Okay, so the moment will be F2 multiplied with D2. But if you notice, if you extend the line of force, it actually passes by the rotational point. So in this case, there are no D2. Your D2 is actually 0. So you can actually zero out this entire expression for the moment. Meaning, takkan ada moment caused by this 60 Newton force, because the line of action is along the rotational point. Accordingly, we are going to repeat the same process for the third force over here. So we are going to call this 20 Newton as F3. So the moment would be F3 multiplied with D3. So the distance which is perpendicular to the line of force is over here. F3, the direction of F3 is to the right. So there is a tendency for the F3 to create a counterclockwise kind of motion along the O axis. Sebab dia counterclockwise, so the magnitude of the moment for the third force would be positive. Repeat the same process for the fourth force over here. So we are going to call this 40 Newton as F4, and it have to be multiplied with the perpendicular distance of D4. So the D4 would be over here. If you look at the direction of the force, it is pointed downward, and there is a tendency for it to rotate clockwise along the O-axis. So because you're clockwise, the magnitude of moment must be negative. So now all the equations are done, so we just substitute the values into the respective area lah. So F1 is 50 Newton, don't forget the negative notation, and D1 is 2 meter. And then plus with F2, D2 kosong lah, so we just ignore this part. F3 is 20 Newton multiplied with D3. Berapa pula D3 dia kat sini? Okay, so if I were to take out this particular section over here, you can look, this is actually a trigonometric triangle. So I just take it out. This angle over here would be 30 degree. This length would be 3 meter. And this is your D3. And you can simply calculate it using the trigonometric relationship of 3 multiplied with sine 30. So your D3 over here would be 3 sine 30. Minus with F4, our F4 is 40 Newton and multiplied with D4. Berapa D4 dia? So you know D4 is actually summation of 2 meter campur 2 meter campur this particular length of this triangle. So the length of this triangle can be calculated by multiplying 3 meter with cos 30. Okay, the following step would be very straightforward. So you solve it and then calculate the total value using your calculator, and you will get a corresponding moment, resulting moment of negative 333.92. What is the unit? So I'm using Newton and meter all the way, so the unit will be Newton meter. So this magnitude can also be rewritten as 333.92 Newton meter. Atau mana dia punya negative value? So you indicate the direction in this bracket. Kalau negative, meaning the direction is clockwise. So this magnitude represents a clockwise direction. Okay, dah siap.